Hello, my name is Russ, and today I want to give a little update about the NAND Minecraft Logic Gate project I've been working on. So, a little reminder, I've been taking these old logic gates in Minecraft and recreating them using entirely NAND gates. For those that aren't aware, the NAND gate in Boolean logic, which is what these logic gates are based off of, can be used to recreate every single other logic gate. And that's what I showcased last time. I then went ahead and made a regular half adder and full adder. I do want to point out I did not make these designs naturally, but these ones I couldn't find anywhere else, so I guess I made them, maybe. But again, using only NAND gates, I recreated the half adder and the full adder, and then I used this to create a 4-bit binary adder. What I went ahead and worked on afterwards is I've been working on improving the XOR, which is this yellow here. I've been working on improving the and I've been working on improving the or, and then I'll get to what that is here in a minute. So first I worked on improving the XOR. The previous design was rather large, and I just wasn't really happy with it. So the first thing I did with it is I wanted to try using these target blocks to kind of help redirect the redstone, because part of the issue is if you try to push these two together, then their inputs are going to get connected and it will muddy the signal. So you want to keep them separate, and the only way to really push these together is to put them both on target blocks, and then have the outputs come do something similar, because if the redstone does point into this block, it powers it whenever the torch is on, and then the stone dust on top of this comes from the output of this NAND here, feeds into another NAND again using target blocks to keep the inputs separate, and then that powers the output. Doing something kind of similar, I tried to, because this design is only about a block thinner, I wanted to continue to make it a little thinner and a little bit shorter. So what I tried to do is, it's a bit of a mess. Effectively, this right here is this first NAND right here. These two right here are going to be the second NANDs, and then this one is this last one over here. It's a bit of a mess, but it does compact things a bit. But it was still a little wide. Sorry, it's shorter, but it's still decently wide. So again, I wanted to just try doing the simplest thing that I could, really, to try to make it a little bit shorter. So effectively getting rid of this middle block by having the redstone dust come up onto these. And then I came to this design. This design, you have our first NAND here, our second one right here, and then this is our last one. These two designs, if I remember correctly, are the same size, but I liked this one a little bit more, just because it doesn't have as many blocks up on top, I suppose. But really, either of them work equally fine. I just decided to stick with this one. Next, I worked on trying to improve the and. There really wasn't any improvements that I could make. I tried just moving this redstone dust between these two torches, and then again putting it on top of these. These could be target blocks if you wanted to simplify it a little bit, I suppose, but I wanted to kind of keep most of them full as much as possible to try to keep it the color schemes matching, and then have the outputs go to the output. And then this was another attempt. It does work, but it's just so large and bulky for technically a block shorter, I suppose, on the output, that I didn't really want to stick with it. I feel like this could be improved further, but I'm not really there. Another one that I couldn't really improve much was the ore. This is the original ore design. And yes, let it be pointed out that you could simply do ore just by having two lines come into each other. Well, I guess that would lead to some problems with back signal. But sticking with the vibe of the NAND gates is what we have here with this target block design. But again, it's 2 blocks tall as opposed to just keeping it in plane, and I wanted it to be mostly wool and not rely too heavily on target blocks, which is another issue of this one, where I effectively just pushed these two blocks together, and I wasn't really happy with any of these. So what I did is I effectively stuck with this original design, but much like I did with the and, is I just kind of pushed this redstone dust to be in the middle, which did widen this final bit here, this final NAND gate, but it's a little bit shorter, although it is the same width. But I figured it worked well enough, and I decided to stick with it. So the next thing I did is I used these new compact designs, and I put them into a full ladder. So it's going to be a little difficult to see because now there's some vertical blocks that get in the way, but it does work functionally identical to the previous full ladder design, which is what you'd really expect to see. And then I made a brilliant decision that took me far too long to work on, and I went ahead and stacked this. So effectively how this stacks decently easy, or relatively easily, because this is the C out. So if you just bring this up a little bit and then wrap it around to come in right about here, then you can go to the next layer, and then the output, you can just bring it down at the end. And that's what we have here. So like for this example, here we have the C out from this first line. It comes around and then goes into the C in for this second layer. And then here are the output lines coming around. They come under and they go into this output here, which is a bit of a mess. I was a little tired when I was working on this. So what we have here, this monstrosity here with the glass towers, is these are just to carry the redstone signal upwards. So we have our A and our B coming upwards, and all of them are the exact same. I didn't use anything to copy and paste these, which I probably should have figured out how to do, which would have saved me a bit of time, but this does work perfectly fine. Let's go and turn these off and we'll do a little bit of testing. So for example, let's say we wanted to add 20 plus, let's just say 5, which should be 30. So we have 16 plus 8 is 24 plus 5. Did I say 20 plus 5 is 30? I apologize. 20 plus 5 is 25, which is the output that we get, and exactly what we'd expect. If we go and turn all of them on, we can see that all of these turn on to add up to 510. If I'm doing the math right off the top of my head, I think it's 510. Yeah, should be. Which is what we'd expect. I know this really wasn't a huge update. There is plenty of other stuff that I really want to work on, and such as working on an encoder and a decoder. I want to decide how to do that because there are designs for those in Minecraft that are very small and compact. And then also feeding those into a 7-segment display. There are designs for those in Minecraft that are very small and compact, but I don't know if I want to just copy one of those or try to adapt one of those into using only NAND gates. What I'm thinking about doing is effectively making one exactly how it works in the real world, and then transforming those logic gates into NAND gates, which would be very large, very slow, and expensive to do in terms of time. But I think it would be more in line with the intention of this project, which is just doing it for the hell of it, pretty much. Yeah, I think that's the next step I'm going to work on, is being able to do inputs, such as, maybe you flip one button and maybe it turns on a copper bulb or copper lamp or whatever it is, to as the input, and then doing the same for both of those, and then having 7-segment display for the output. I don't know yet. I don't know exactly how I want to do it yet, but I'll be sure to work on that and keep y'all posted. Thank you for watching. I hope you have a good rest of your day.